English. So this is the problem. We have an equation given 2x cubed for a quadratic polynomial when x tends to minus infinity. If you put here, so this will also tend to minus infinity, right? X cubed, x cubed, x tends to minus infinity, x cube also will tend to minus infinity. So it starts from here somewhere like minus infinity, and when x tends to plus infinity, the function takes the value plus infinity. So it's clear that function comes from down, or the graph it comes from down, and somewhere it takes turns here and there, and then finally it has to go up, right? So how can a quadratic polynomial look like? It can look like this. It goes like here, and something like this, starting from minus infinity going towards plus infinity. So in this case, like what I draw, you can see that there are three real roots. Root is the number of points where it cuts the x-axis. So here are three roots, three real roots. So but we want only one real root. So what kind of case that can be? Here, like comes from here. There's a one real root. Now it takes a turn, goes down, and goes up. Right? This kind of thing. This just has two turn point, the sharp turn points are the minimum or maximum points. The two points where its derivative is 0 and only one root. Or it can also have another case where it goes like this, takes a turn here only, goes up, goes down, goes up, and has another real root. So these are the two possible cases for roots. Now let's also check its antiderivative. It is known as fx. So fx is 2x cubed minus 6x plus 2 sine alpha plus 3. So f dash x, or df by dx, it will be 6x square minus 6, which can be written as 6 times x minus 1 into x plus 1. So there are 2 points where f dash x is 0, and these points are x equal to plus 1 and x equal to minus 1. So if this in any one of these two SR graphs, this point will be minus 1 and this point will be plus 1, or this point is minus 1 and this point is plus 1. So which of these will be our plot? It's not required, but still we can find it out. See, f of 0. What is f of 0? F of 0 is, if you put 0 here and here, you get 2 sine alpha plus 3. Since any sine function, it belongs from minus 1 to plus 1. So f of 0 is definitely greater than 0, because even if it's the minimum, minus 1, then this will be minus 2 plus 3. This is plus 1. That's the minimum possible value. So f of 0 is obviously greater than 0. This means this is rejected, and this is the possibility. This point, this value could be greater than 0. So we have such kind of graph. Now, this was not a question. This was just an extra thing. Ready? So let's plot it first. I'll draw it. The graph is this one. It takes a real root at some negative x, goes up, takes a u-turn, then takes another minima at x equal to plus 1, at x equal to minus 1 there's a maximum, and at x equal to 0, it takes some positive value. We are asked to find the largest interval for alpha for which this condition would exist. So if we see this case, we know that f of minus 1 into f of plus 1. Now both these terms are positive, so this term should be greater than 0. We can also apply it in parts. F of minus 1 is greater than 0, f of plus 1 is greater than 0. Now this has to be true. If f of minus 1 is not greater than 0, then it has to take a turn down, and this value will come as negative. So both the conditions are important. So f of minus 1 is, if you substitute minus 1 in the equation was x cubed minus 2x cubed minus 6x plus 2 sine alpha plus 3. This was fx. So f of minus 1 will be minus 2 plus 6 plus 2 sin alpha plus 3. This is 4 plus 7 plus 2 sin alpha. And f of plus 1, it will be 2 minus 6 plus 3. So 2 plus 3, 5. 5 minus 6 minus 1. Minus 1 plus 2 sin alpha. So if you apply this condition, or we can apply individual conditions, 2 sin alpha plus 7 is greater than 0, and minus 1 plus 2 sin alpha is greater than 0, and sin alpha is greater than minus 7 by 2. This condition is not possible actually. Sorry, sin alpha greater than minus 1 by 2. This is sin alpha greater than minus 0.5, which is always true because sin alpha belongs to minus 1 to plus 1. This condition is always true. You need to do anything like nothing conclusive from this. This turns out to be 2 sin alpha is greater than 1. Sin alpha is greater than 1 by 2. This gives something conclusive because sin alpha or any sine function, it belongs from minus 1 to plus 1. So if you see the graph of, if you remember the graph of sine function, something like this, right? And in 0 to pi, the value is positive. This is the graph. At pi by 2, it takes value 1. We do this. And we were given the range of alpha as 0 to pi. That's why I have drawn just this half. This is, what is this point? When does sine alpha take value of 1 by 2? It's 30 degree, right? 5 by 6. And this angle is pi minus 5 by 6 or 5 by 6. Hence, the interval comes out to be pi by 6 to 5 by 6. And that is the answer. Alpha belongs to pi by 6 to 5 by 6. Right? So, that's the solution. Thank you.